Hello everyone, welcome to today's video on geometric dimensioning and tolerancing, which is GD&T for short. This is the first video on the beginner's course to GD&T and I am your presenter Adi. Let's get started. Before we start discussing the concept of GD&T, there arises a natural question, why do we need GD&T? Why can't we go with the straightforward dimension with linear tolerances? For that, let's assume we are going to make a part that looks something like this. It's a simple metal bar which we want to dimension as shown in the picture. So the bar has a span of 500 millimeters and a width of 100 millimeters and a height of 50 millimeters. And all these dimensions have a tolerances of plus or minus 1 for the manufacturer. So we are good with the drawing and we hand it over to a manufacturer who makes this part and he comes up with a part like this. Should we accept this part? Let's find out. From a strict dimensional standpoint, it is actually pretty good. The span is within our limit, the width is within our limit, but this height dimension that kind of catches our eyes, right? So it kind of looks arched from the front view. So we want to make sure that it is good to go from a functional as well as a dimensional standpoint. We go back to the manufacturer and ask him, hey, the part does not look straight at all. What have you done? The manufacturer says, look at the drawing you sent. It measures 50 millimeter on the height. So I took some random samples across different areas and it looks okay to me. That's what he says, and we cannot argue with him because we haven't mentioned anything else apart from this on the drawing. So we have to suffer the losses. Whether we should accept the part or not, it depends on the conversation between supplier or the manufacturer and the designer. But from a literal drawing standpoint, we cannot reject this part because there is no other control except all these linear dimensions and tolerances. So pause and think, should we accept this part or no? Please let me know in the comment section. Now, to help us win the argument with the manufacturer, whether or not to reject or accept the part, first rule of GD&T comes to help. According to ASME Y14.5 standard, first rule of GD&T states any part which is manufactured according to the print with a particular tolerance, it has to have a perfect form at MMC. MMC stands for maximum material condition. So the dimension at which the part is the heaviest, and LMC stands for least material condition where the part is the lightest. When we go back to our previous slide, this dimension 50 plus or minus 1 has an MMC of 51 and an LMC of 49. So when the manufacturer comes up with an actual part that looks like this, on the second image, we can go ahead and accept it because although the part is arched or curvy like this, it still fits within that MMC zone, so we can accept it. And we cannot accept if the part is deviating from this green zone where the MMC is. There are other certain scenarios where we can and cannot accept the part although it is within this green zone. We can discuss those conditions in the upcoming slide. When we look at this one, the first picture, we have a wavy part. When we zoom in real close using a microscope or a magnifier, you can look at the part with some discontinuities on its surface. But when we run a dial gauge or a vernier caliper or a CMM over this part to measure the dimensions, it is perfectly within our limits. So our limit is between 49 and 51. The part can float within that range. So this is completely acceptable. It is acceptable in terms of size as well as in terms of the first rule of GD&T, which is perfect format MMC. And then a case which is not acceptable is this part. Although it lies within the MMC zone, the size tolerance is not met. If you can remember the previous picture which showed 50 plus or minus 1, the part can float only between 49 to 51. It cannot go to 47 or 48. So the first rule of GD&T does not imply all the dimensions which are within MMC are qualifiable. No, not like that. Only if the part is within the size tolerance, also within the MMC perfect format MMC, it can be qualified to be an acceptable part. So now that we've learned about first rule of GD&T, it is equally important to know the exception to this rule as well. Whenever, as a design engineer, we feel that it is unnecessary for the part to have perfect form at MMC based on the function of the part, we can communicate to the manufacturer about its exception. The way we do that is by using this symbol I, which is circled. This symbol can be tied to any dimension to communicate to the manufacturer about the exception of the rule. In that case, the manufacturer will have more liberty and more leeway to make the part, which in turn is suitable for the design intent, also might reduce the cost of the part. And that's pretty much about first rule of GD&T and its exception. Here, you may notice that I have added a symbol which is part of GD&T and one of the fundamental symbols in GD&T. Take a guess and let me know what this symbol means, and we shall talk about this symbol in the next video. Thank you very much for watching. If you like this video and found it informative, please hit the like button and subscribe for more content like this.